Have you ever wondered, how does the life of a star unfold in the vast universe? Just like living beings on our Earth, stars too have a life cycle. They are born, they mature, and they die. But their life journey is marked by transformations so breathtaking, they're nothing short of cosmic ballet. From being a mere cloud of dust and gas, a star evolves into a burning sphere of plasma, illuminating the cosmic stage. It then grows and changes, living a life that can span billions of years. And when the final curtain falls, it dies in a spectacular explosion, leaving behind remnants that may become the seeds for new stars. This is the life cycle of a star, a journey of creation, transformation, and rebirth. So, are you ready to embark on this cosmic journey? Dive with me into the cosmic dance of stars and explore their mesmerizing life cycles. In the cosmic nursery, every star begins its journey as a cloud of gas and dust. This cloud, or nebula as it's scientifically known, is an astronomical wonder, a vast expanse of space particles suspended in the cosmos. Picture, if you will, a nebula, a seemingly serene and silent entity, brimming with the potential to give birth to a star. Inside this nebula, something remarkable happens. The tiny particles of dust and gas start to move, slowly at first, drawn together by the invisible force of gravity. A dance of cosmic proportions ensues as these particles begin to clump together, growing ever denser and hotter. This is not a rapid process, mind you. It takes hundreds of thousands of years for these particles to come together under the relentless pull of gravity. This entire process is much like a celestial ballet, choreographed by the laws of physics. The nebula, once a tranquil cloud, now becomes a bustling hub of activity as the particles continue their dance, swirling and spiraling inwards. As they do, a new entity begins to form at the heart of the nebula, a protostar. This protostar is the embryo of a star, a celestial infant, if you will. It's a hot, condensed object at the center of the nebula, growing ever larger and hotter as more and more material is drawn into it. But even this is not the end of the journey. The protostar continues to grow, fueled by the nebula that birthed it. The particles of gas and dust continue their inward spiral, feeding the protostar, helping it grow denser and hotter. And then, something extraordinary happens. The protostar becomes so hot, so dense, that it sparks a reaction at its core. The atoms within start to fuse together, releasing a tremendous amount of energy. This is nuclear fusion, the process that powers every star in the universe, from the smallest red dwarf to the largest supergiant. As gravity continues to pull in more material, the protostar gets hotter and denser, marking the beginning of nuclear fusion and giving birth to a star. The cosmic ballet concludes, and the nebula's masterpiece, a shining new star, takes its place in the universe. With the birth of a star, begins the longest phase of its life, the main sequence. Let's dive into this fascinating period of a star's life, where the magic of nuclear fusion takes center stage. The main sequence is a significant and enduring part of a star's life, spanning billions of years. It's during this phase that stars like our sun shine bright, radiating energy into the cosmos. But what powers this radiant display? The answer lies in the heart of the star, where nuclear fusion occurs. Nuclear fusion is a process where atomic nuclei come together to form a heavier nucleus. In the heart of a star, intense pressure and temperature combine to create the perfect conditions for fusion. Here, hydrogen nuclei, or protons, collide and fuse together to form helium. This process releases an enormous amount of energy, which we perceive as the star's glow. Now, imagine if all this energy were to push outwards uncontrollably. The star would blow itself apart, right? But that's where the intricate balance of the universe comes in. There's a delicate equilibrium at play between the outward push of radiation pressure and the inward pull of gravity. Radiation pressure, generated by nuclear fusion, attempts to expand the star, while gravity, ever the cosmic disciplinarian, works to hold the star together, preventing it from expanding too much. This tug-of-war between radiation pressure and gravity is a continuous process and maintains the star's size and shape during the main sequence. It's a stellar balancing act that lasts billions of years, but nothing lasts forever, not even in the cosmos. As the star continues to burn its hydrogen fuel, the supply gradually dwindles. After billions of years, when the hydrogen fuel is finally exhausted and fusion slows, the star grows unstable, marking the end of the main sequence. After billions of years, the star exhausts its hydrogen fuel, marking the end of the main sequence and the beginning of the next stage. Stay tuned as we explore what happens when a star enters this intriguing new phase of its life. As stars age, they expand and cool down, transforming into red giants. This metamorphosis is quite a spectacle in the cosmic theater. As the hydrogen fuel in the star's core exhausts, the core contracts and heats up, igniting the helium into a helium flash. This process gives birth to heavier elements like carbon and oxygen. The outer layers of the star, no longer held tightly by gravity, start to expand. The star grows hundreds to thousands of times its original size, becoming a red giant. But why red, you might ask? Well, the surface temperature of the star decreases as it expands, causing it to emit light towards the red end of the spectrum, thus earning it the name red giant. But the life of a red giant is ephemeral. It can't sustain the fusion of heavier elements for long. The core collapses under its own weight, and the pressure outside the core propels the outer layers into space. This celestial spectacle, known as a planetary nebula, paints a vivid picture in the cosmos with intricate patterns and bright colors. Hidden within this cosmic artistry is the core of the star, now exposed. This core, stripped of its outer layers, is about the size of Earth but holds half the mass of our Sun. It's a white dwarf, named for its white-hot temperature. The white dwarf cools down over billions of years, radiating its heat into space. Its light fades and it slowly turns into a black dwarf, a cold, dark remnant of a once vibrant star. It's a stellar graveyard, if you will. From a fiery birth to a quiet death, the life of a star is a tale of transformation and endurance. The white dwarf, a stellar corpse, is all that remains of a star like our Sun, but for heavier stars, the journey continues. And what a journey it is, filled with cosmic fireworks, celestial art, and the unending dance of creation and destruction. For more massive stars, their demise is nothing short of a cosmic spectacle. They go out with a bang in a supernova explosion. A supernova is the cataclysmic death throes of a star, and it's one of the most violent events in the universe. But don't let the violence fool you. In these explosive death throes, something quite magical happens. During a supernova, the star's core collapses under the force of gravity. As the star's outer layers crash inward, the immense pressure and heat cause a nuclear reaction. This reaction results in the creation of elements heavier than iron. Gold, silver, platinum, uranium, and all the other elements heavier than iron in the periodic table owe their existence to these stellar explosions. When you wear a gold necklace or a platinum ring, you're literally wearing star stuff. Once the supernova explosion has run its course, what's left of the star's core becomes one of two things. If the core is between about 1 and 3 times the mass of our Sun, it becomes a neutron star. Neutron stars are incredibly dense, with a teaspoonful weighing as much as a mountain. They're so dense, in fact, that a sugar cube-sized piece of neutron star would weigh about as much as the entire human population. If the core is more than 3 times the mass of our Sun, it collapses into a black hole. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They're fascinating and enigmatic objects that continue to puzzle scientists. From a humble cloud of gas and dust to a magnificent supernova, the life of a star is a testament to the cosmic law of change and transformation. In its death, a star gives birth to elements, neutron stars or black holes, enriching the universe and paving the way for new celestial bodies to emerge. It's a cycle of life, death, and rebirth, played out on a cosmic scale. So, the life of a star, much like ours, is a journey filled with transformation. Born from the cosmic dust of a nebula, it enters the main sequence, burning bright and steady. As it ages, it swells into a red giant, shedding its outer layers. Eventually, it shrinks down to a white dwarf, or, for the more massive stars, explodes in a supernova, possibly leaving behind a neutron star or a black hole. Next time you look up at the night sky, remember, each twinkling star is living out its cosmic journey, from birth to death, in the grand theater of the universe.